So today I will continue about the symbols. This symbol will be frequency on the test. So I will begin right now. So we can see that they are two wire, but they are not connected because they don't have the dot in here. If they get connected to wire, they should have the dot in here. This should be important. The next one is about galvanometer. Galvanometer they use for very small current below than 1 milliampere, and galvanometer they use about deflection of moving core. It means in the galvanometer they have the smaller current and they have the core go around the galvanometer. If the current go inside the galvanometer, the boiling they will move on the right, so that we can get about what is the current of the ammeter, but they just use very small current. The next one is about DC and AC. DC they will have the positive and the negative, but AC they have the wavelength. Because in the AC they will use the hertz. In the DC there is no hertz. So that's on the test, do we have the frequency in this DC? So the answer is hertz is 0 because there is no hertz in the DC. This is the speaker. Speaker they transform about the electrical power to the sound power. This means when we have the electrons go through the speaker, they create the sound in here. The next one is about potentiometer. Potentiometer they will use the third terminal. It means that the third terminal on the top of the resistors they will change about the amount of resistance. So that we have two symbols. They have the same symbol, but they just use one rectangle, one about the wavelength, so that we can know that that's about potentiometer and that's a potentiometer, so they are same. The next one we have oscillator. Oscillator they transform from DC to AC. You can see that in input we use the DC, they go to the from positive and the negative, and AC only one. So that's another name of the oscillator is the amplifier. This means they transform from DC to AC. The round we have three symbols. We have classic, arch and signal. The classic we have three slides like this, and the arch we have three horizontal line horizontal in here, and the signal we have the upside down triangle. Three symbols in here that will be on the test, and we need to learn the round symbol too. The ASVAB test they will ask what's this symbol. You can see that they provide a symbol for you, and we have A, B, C, D. In here you can see that cannot be the speaker. The speaker should be like this. This cannot be the resistor. Resistor should be like this. That cannot be ammeter because ammeter should be like this. So that's the answer for this symbol is about B. This test they will ask the symbol. We know that this is not about the DC because the DC it should be like this. That's not transistor. Transistor should be like this. That cannot be the fuse because the fuse should be like this. So that's the answer for this symbol is about AC. all of them are field symbol except. So we see that to know the fields, this is about the fields. This is not the another standard fields too. This is about the fields, but this one is about the light. So that's the answer for this question is about D, because these they are the fields. So that on the test they will ask about which one is not a field. So let's see about D. Question is, what is the symbol? That is not resistor. So we have that in this question we see that number C is about the fuse. This one is the resistor. This one is about variable resistor. So that the answer key for this question is not resistor, is about C. So what is the symbol of this question? We can see that the meter, there should be letter A. Galvanometer, this is about this one, but AC is about this one. Ohmmeter, it should be like. So that after we do everything, we can see that this one should be about B. And you should remember that if they have the letter G like this, they can be about galvanometer. So that is so simple. Just remember letter G and good answer is B. I will talk about conventional current and electron current. On the test, they will ask about the difference between the conventional current and electron current. So I will draw the diagram, so I will show for you. In the conventional current, they will go from the positive to the negative. This means they will go from positive to the negative. And about electron currents, they will go from the negative to the positive. To distinguish about the electron current and conventional current, because electron it should be about the negative. We learn about electron should be the negative, so that the negative should go back to the positive, so that they can combine together. But about conventional current, they are opposite current. They go to the positive to the negative. So on the test, they will ask what's in between the conventional current and electron current. On the test, they will ask what is the correlation of conventional current and electron current. A conventional current will go through positive terminal to negative terminal. B, electron current will go through positive terminal to negative terminal. C, conventional current will go through negative terminal to positive terminal. D, both A and B are correct. So in here we will analyze in each question. We say that conventional current will go to positive to negative. So this one is correct because conventional current is the opposite flow of the electron current from positive to negative. So that is correct. Electron current will go through positive terminal to negative terminal. This is wrong because the electron should be go from the negative to the positive. conventional current will go through negative terminal to positive terminal. This is wrong because conventional current they will go to the positive to the negative. So that C is wrong because we have B is wrong in here. So that's we cannot choose D. So the answer for this question is about A. The next one they will provide question like this. What is the current of electron current? We have A, high potential to the low potential, and we know that the electrons that go through from the high potential to low potential because they want to go to the positive terminal, so that they reduce the electron. So that's the A correct. The next one, they go through the less resistance. That's it correct because some electron they want to find the best way to meet the positive side. If they have too many resistance, they very hard to move, so that they can get about less resistance. C, they go the longest wire as much as possible. This is wrong because when we write the diagram, like this, we have the fuse in here, and it can be about the load. So if we put the connected like this, the electron they will go to the shortest way to meet the positive side. They don't go to the load or the fuse in here because they have the resistance. So that the electron they should go the shortest wire, not the longest wire. So that's the answer. A and B is correct. As fast, and I ask like this. What is the voltage and the current in this diagram? We have A, B, C, D. On the diagram, you can see that the switch is open. You can see that the switch is open. Therefore, we don't have the current of the electrons, so that we don't have the current and they don't have the voltage. So the answer key for this one is about B. Be careful that some students they will choose A. They thought that they have the current is A voltage and they calculate the ampere in the resistor. Therefore, they put about 1, and that's why this is wrong. And we need to know that if they open the switch on the direct, so that answer should be 0. So the answer is about B. I will talk about the series and the parallel. In the test, they will ask to calculate about the current, voltage, and about the resistor. So we have the series, and I show the formula of the series and parallel. In the series, we have 2 resistors in here, let's see R1 and R2. In the ampere, we can see that the current will be same for in the series. It means I1 equal I2 and equal to I for the whole the series. The voltage is be about V1 plus V2. We know that V1 is about the voltage in the resistor number 1, and V2 is about the resistor number 2. The total in here there will be V1 plus V2. This is the whole series in here. About the total resistance, we have R1 plus R2 in the series. Therefore, you need to know the formula and how to understand about the formula. So why we have I1 equal I2? Because when the voltage push the electron, I1 and I2 in the same line in here. That's why we have the same electron And why we have the V1 plus V2? Because in the voltage they push through the R1, they reduce the force. So that's R2 is reduce the force too. So that's we have share the electromotive force for R1 and R2. Our resistance we just sum together. The next one, that's about I, that's the ampere, and that's the current. In about the parallel I1 plus I2, in the voltage we have V1 and V2 are the same one together, and the resistance we have 1 divided by R equal to 1 divided by R1 plus 1 divided by R2. In here, why we have I1 plus I2? Because the flow of the electron, they will separate them in the parallel. This means that we have some total amount of electron they go through for R1, and we have total the amount of the electron they go through for R2. This means they separate about the flow of the electron. We have V1 equal V2 because when the force push at the same time, so that the force they will go through in the same for both R1 and R2. That's why we have V1 equal V2. We have the force in here, and this is the flow of electron. So that's the way we understand about the series and parallel. So I will do some the practice so you can understand. On the test, they will ask about what is the total resistance of this diagram. We can see that we have 3 resistors in here, and both of them in the one series. This means they are one line together. They are one line together, and the electron go through. So that on the diagram in the one series, so we can input the formula. Therefore, we have the formula to apply this diagram. So we have R1 is about 30. The second one is about 20. The last one is about 10. So that's we have total is about 60 ohm. And the answer for question is about B. In the next diagram, they will ask what is the total resistance in this diagram. We can see that is about the parallel, and we have 2 resistors in here. So we can apply this formula. So because they are parallel in this diagram, we can apply like this. One divided by 20 and 1 divided by 20. The sum to fraction in here is about 2/20, like this, so that we can simplify them. Let's say 1/10 because we divide numerator and denominator by 2. So that we have R is about 10 ohm. So the answer for this question is about D. Now the series and parallel. So we have the parallel in 2 resistors, and we have another resistor in the series. So we call them that's about series and parallel. First, to calculate this one, you need to calculate about the parallel first. Later that we can sum with the series and we got the total about the resistance. In the parallel, we just apply again. So let's see for the parallel. So we just apply this formula. Because R1 and R2 is about 10 ohm and 10 ohm. Then later that we can calculate them is about 1/10. 1/10 is about 2/10. And after that we reverse the fraction. That's about 10 divided by 2. So that the resistance in the parallel is about 5 ohm. We have 5 ohm in here. That's about the parallel. So we have R equal R star in here plus about R3. This one we just calculate about 5 and R3 is about 10 in here. Sum together we got about 15. The answer for this question is about D. So the tips to do about the series and parallel, you need to do the parallel first, then go back to the series. So I will introduce the finals in the ASVAB. What is the total resistance in this diagram? In this diagram, we can see that we have the parallel. In this parallel, we have 2 resistors on the series. So the tips is that we need to calculate the series, then go to the parallel. So in the final, we calculate the series at the end. So we sum 2 resistors in here. First, we have one star. We have 5. We have 5 and number 10 on the series. On the top one, we got about 15. The next one, that's about the parallel. So in the parallel, we have 1 R2 star, about 1 R plus 1 R number 3. 1 over R first star is about 15 plus about 15 over there. So that the total is 2 over 15. The R2 star in here is about 15 divided by 2 is 7.5 ohm. After we got about R2 star, we got about R on the whole is about R2 star plus R number 4. R2 star in here we calculate about 7.5 plus about R number 4 is about 10. So that we got about 17.5. The answer is about 8. Question is, what is the current of resistor R1? So in here, let's see about the series. Because this is the series, so we know that I equal to I1 equal to I2. So if you want to calculate the I, this means we calculate the whole series and then we can find about the series. After we calculate the I, we can find the I1 very simple. So we calculate about the R first. We have R is R1 plus R2 because that's about the series. So that we have 15 ohm. We have I equal to V divided by R. We know that V in here is about 30. R is about 15. So that's really about 2 ampere. But let's see about series. We know that I equal to I1 equal to I2. So the I1 is about 2A. So that's the answer for this question is about A. What is the voltage of resistor R1? So after we calculate everything, we have the I1 in here. This is about 2 ampere. We just apply for the formula. We have 2A in this R1, and we just apply the formula V1 equal to R1 multiplied with I1. R1 we have 5, and then we multiply with 2. So we got about 10 voltage. So that the answer for this question is about B. Because if we have the I1 and I2, you just use the R1 or R2 in here, multiply with I1, and you can go about V. And this is so simple for about the series. In this diagram, that's about the parallel, and we can use this formula for calculate the current. We know that V is equal to V1 equal to V2. So we have the formula from the parallel, and we want to calculate the current of the R1, and we have I1 V1 divided to R1, just like that. And we know that V in here is about 30, so that the V1 should be about 30, and we divide to R1. R1 is about 10, so that we got about 3 ampere. The answer for this question is about A. So today we will talk about DC and AC. DC is about direct current. AC is about alternative current. So on the test, they will ask how many kind of current. We only have DC and AC. In DC, we don't have Hertz. AC, we have Hertz. In DC, they flow only one way. The electron go in only one way, from negative to positive. AC, they will change one way, then later that they go back. So that AC they will change many times, and we need to learn that how to calculate the Hertz. Hertz is about T equal to 1 divided by F. In T is about time of 1 period. For example, we have hertz is about 50. No, frequency is about 50 hertz. Therefore, T is about 1/50. This is about 0.002 seconds. This means that in one period, they finish only 0.02 seconds. And the hertz is about how many times they change the current in 1 second. What are two types of electrical current? In here, we have only AC and DC are the correct answer. In DC, we have A, B, C, D. We know that DC is about one way of current. So that there's one way, so they don't have change another way. So that's about 0. This is what I will ask. What is the unit of frequency? We have A, B, C, D. We know that frequency they should be about hertz, and so that this is about A. So we choose A. We will learn about the rounding. So we have traffic, urge, and the signal. We will concentrate on the 3 basic rounding, and they will be on the ASVAB test. Traffic, they use for the automobile, the train. For example, we have the car like this. We have the small metal like this. Here, this is about the gas tank. Because when the car move on the street, we have the air, they make the friction on the gas tank. That's why we have some small electric in here. So that we have the routing connect to the gas tank and near to the RAM, so that they can transform the flow of electron go out of the gas tank. Because if too many electrons near the gas tank, they will make explosion. That's why we have the chassis for the automobile and train. The next one is about earth. We know that we have the building, and we have the antenna in here. In here we connect to the RAM, and that's it. We call about the earth routing, because when we have the thunderstorm, they will transform the electron from the thunderstorm to the RAM. So that we call, that's about the earth RAM. The next one, that's about the signal. Signal just like this. Just like in the house, we have the cable. In case there's so many the surge of electrons, the routing signal, they will transfer to the router, and we can save the cable. This one they use the signal routing to save the cable. So that's why we need to learn about different kind of the routing, and that's it on the ASVAB. The following symbol are not routing. we have A, B, C, D. In here, we see that B is not the routing because this is about the diode. Be careful. Many times, many students they saw the triangle. They thought that's about the signal routing. So they choose about C and B. They confused about B and C. They thought the triangle is about the another routing, but actually that's about diode. Then we'll talk about the power, and we have the formula. That's the basic formula. That's P equal to V multiplied with I. And in here, we have the units. That's about watt. And this is about the unit of power. And we have another unit. That's the joules per second. And in here we have noticed V is about voltage, I is about A. So that we have the unit, that's about V multiplied with A. That's about the unit of power. And we apply the Ohm's law. We have R equal to V divided by I, but we can transform to R inside the power. For example, we will have V is about R multiplied with I, and I equal to V divided by R. So that we transform the formula. We have V in here, that's the RI, so that's the RI. This one be from V equal to R multiplied with I, so we have R multiplied with I power 2. And the next one, that's about I. In the I, we have V divided by R, we transform them. So that we have the formula is about V power 2 divided by R. So that's it, the basic that we need to learn to pass the ASVAB. So in the ASVAB, they will ask what is the corrected power formula. We have A, B, C, D. In here, they just use about R and I. We know the formula is about V equal to V multiplied with I. And in here, we transfer them the V to R, and we have the Ohm's law. We have V in here, and we transform to V equal to R multiplied with I first. And we have R and I, we put in here. Then we have I multiplied with I. So that's the answer for this question is about C. In the ASVAB, I will ask if voltage go up 8 times, current reduce 2 times, what will the power change? We have A, the power will go up 4 times, B, the power will go up 8 times, C, unchanged, D, the power will go down 2 times. So in this question, we have B equal to V multiplied with I. So in here, we have the voltage, they go up 8 times. but the current reduced 2 times. So that's the new voltage is about AV, and the new current is about I divided by 2. So we have A and 2 that have different number. A divided by 2, V multiplied with I. So we have A divided by 2 is about 4V. Therefore, the answer for this question is about A, because they go up more than 4 times than the original power. About the measurements, we will use about 5 types of the meter, and they will be on the ASVAB test. Let's see about ohm meter, voltmeter, ampere meter, galvanometer, multimeter. In the ohm meter, we will have like this. We will put two connection to the resistor. That's the way we do about the ohm meter. Voltmeter and ampere meter a little bit different. For example, in about voltmeter, we should put about parallel, because in the parallel we have V equal to V1 equal to V2. So that's why we need to put the parallel so that we can find the voltage of the battery, and that's why we put the parallel. On the ampere, we need to be in the series, because the formula of the ampere in the series is about I equal to I1 equal to I2. So that's when we put in the series, we can calculate the whole unit of the ampere. So that on the test they will ask how can we put about the voltmeter and ampere meter. In the voltmeter, they should be about parallel. In the ampere meter, they should be in the series. You should remember this one. This is so important. The next one that's about galvanometer. Galvanometer is used for the small current, just like the tiny diagram like this, and we should be very low voltage, low current. The final is about multimeter. Multimeter, they will become about VOA. VOA is mean about they calculate about the voltage. They calculate about ohm, and final I is about ampere. That's why we have VOA, and that's why we call multimeter, because multimeter they can measure all of them, O, V, and I together. We have a question: which of the instrument cannot measure the current? We have A, B, C, D, and we can analyze in its answer key. In the answer A, we have galvanometer. Galvanometer, they just carry about very small, below than 1 milliampere. So they can measure about the current. Multimeter, we have VOA. We have letter A in here, that's the ampere, and ampere, that's about current. We have ampere meter. because that's the ampere meter, that's the current, yes. And the last one is a voltmeter. Voltmeter, they just measure about the voltage. So that's the answer for this question. Is about a question: how can we put voltmeter? So we have A, B, C, D on the about voltmeter. We need to put in the parallel, because in the parallel we can get about V equal to V1 equal to V2, so that we can calculate about the voltage of the whole diagram. So the answer for this question is about A. And we put ambimeter. In the ambimeter, we need to put in the series. And this is the way we put about ambimeter. So we have B and C are the correct because they asked about on the series. And the answer for this question is about B. In this question, we will learn how to read a digital watt-hour meter. This is on the ASVAB, and we need to learn how to read about watt-hour meter. In here, we can see that 0, 1, 2, 2, 9, they go to anti-clockwise. 0, 1, 2, 3, they have clockwise, anti-clockwise, and clockwise. So be careful now about that. We need to care about from order from 0 to 9, so that we can figure out which one is the clockwise and which one is the anti-clockwise. So for example, so now I will follow from each block, and we will figure out what is the total amount of the watt-hour meter. So in here, from 0 to 9, that's about anti-clockwise. And in here, we see that 1, 2, 3, and this point is still in the middle between 2 and 3. So that because this number below than 3, so that they need a number 2, and this should be about 2 because they still below than 3, and they still anti-clockwise, so that the answer is about 2. The next one, that's about clockwise, and the voltage is about number 6, and this should be about 6. This one is a little bit difficult, so right now that's the anti-clockwise, and in here we have number 9 and number 8, and the voltage is between 9 and 8. In this one we have 1, 2, 3, 4, 5, 6, 7, 8, and number here is below than 9, and we have the anti-clockwise, so that number 8 is the lowest, and the number in here is higher than number 8, so that the answer in here is about 8. The next one, that's about clockwise. We have this voltage between 4 and 5, and we see that the number in here below than 5 is higher than 4. So because that's based on the clockwise, we have number 4 in here, so that's about 4. And later that we can get the number, that's about 2,684 watt-hour. And another thing I want to mention, if they ask about what's the instruments, instrument to calculate the power, we just say about watt meter. That's it. Watt meter they will use to measure about the power. let's see, I got in the real aspect what's a kilowatt-hour meter, and in here we have the 4 clock, and we need to find the number. In here we have number 5 in this question, so that C and D is wrong because they put number A. We have between A and 7, and we see that that's about clockwise, and we see the pointer is higher than 7, below than 8, so that is about 7. That is correct. This is about anti-clockwise, and we see that number 9 and number 0, and this the pointer higher than 9, below than 0, and we can see that's about 9. That's correct. And the last one is about clockwise. We have 1, 2, 3. We know that the pointer between 2 and 3, and this number is higher than 2, below than 3. So that's about number 2. And the answer for this question is about A. On the aspect that we asked about conductive materials, we need to learn about 4 types of the materials. They have the highest conductivity and the lowest conductivity. We know that silver is higher than copper, copper is higher than gold, gold is higher than aluminum. And in here, the copper is the most usage. Why they don't use the silver? Because the silver is so expensive. This one is the cheap, and that's the reason why we use the copper than the silver, because the silver is so expensive. That's not economical. That's why we choose the copper. And in the test, I will show about the real test. On the real aspect that we ask, what is the highest conductivity? So the answer for this question is about A. We just study about theory. Next question, why do we use copper than silver for wire? A. Silver is higher conductivity than copper, but expensive. B. They are not used anymore. C. Silver is so heavy. D. None of them. So on the answer key, that's about A. Because silver is higher conductivity, but they are so expensive, and we don't have enough money to use the silver on the wire, so that we use copper.